So it only added one hydrogen ion at a time. So only take one H off of the water to make that. And make sure you have your PO4 minus 2, so it's acting like a base, right? And then the magnesium would have made magnesium hydroxide not strong. Okay, so it doesn't happen. All right, what about the next one? Neutral, okay, because neither ion undergoes hydrolysis because it would just make a strong acid or base. What about C? Acidic, okay. All right, so for that one, your Fe plus 2 is the one that reacts, and it should only had one OH added to it at a time. So make sure you put the right charge on it. And if you were really amazing, you may have done it this way. Did you? Okay. Because the transition metals really would have water of hydration on them, and they would add with the water and all of that. So that's really what happens. Well, you like to be really amazing. Yeah. You don't have to be really amazing all the time. Like, to figure this out, you really don't have to be amazing. Only if you were trying to write the real equation. Okay. Yeah.
Why is there always 6 waters?
There aren't always, so that's why you don't always have to be really amazing. There's different transition metals tend to have different, they call them coordination numbers, different number of water molecules that hook on.
Is there a way you can tell that just by looking at the periodic table?
Now you have to memorize them. Yeah. Okay. So you don't have to be amazing all the time. Okay. What about the next one? Acidic, basic, or neutral? Basic. Okay. Which ion undergoes hydrolysis? Acetate. Okay, the acetate ion is the anion of a weak acid, and it reacts with water to make that and that. Okay? I want to make a point here. A lot of times people get confused because they think it's making an acid, it ought to be more acidic. Okay? But having acid molecules does not make something acidic. It's having hydronium or hydroxide ions that makes it acidic. Okay, so it doesn't matter how many of these you have, really, because they're not broken down. What matters is the hydronium and hydroxide. Okay? All right, what about the last one? Acidic, basic, or neutral? Okay, that one's basic. Okay, now your first thought might have been neutral because you thought calcium comes from calcium hydroxide, that's strong, and SO4 comes from sulfuric acid, that's strong. Okay, but if you only add one hydrogen on at a time, you actually get this, and all acids with negative charges are weak acids, so this will stay in this form almost entirely. So it is actually going to be basic because this part's only going to there. Okay? All right, what about on the pHs? What did you get for all of them, Chase?
I haven't got that for you.
Oh, did you get the first one, eh?
No.
Could you do it in your head? NaCl, would that be acidic, basic, or neutral?
That is neutral.
So the pH would be
7.
7, okay? All right, we're good on that one. Neither one of those undergoes hydrolysis. Okay, what about the one underneath it? Let's see, did you get it, Sarah?
B,
Yeah.
less than 7.
Okay, so you think it would be acidic. You guys agree? Okay, because just like this amazing one up here, all right, the same kind of thing happens. The iron ion would react with water to make hydroniums, okay, and this, if it did make HCl, would just break down, so that doesn't happen. Okay, so Dylan, Mogul, what did you get for C?
Acidic, so it's going to be less than 7.
Okay.
Greater than 7. C? Acidic.
Yeah, that's less than 7.
Less than 7.
Right, okay? Because that would have been this ammonium ion reacting with water. You can't really read it, but that's what it would do, okay? What about the last one? Dylan Carter.
Would that one be neutral? 7?
What was your logic?
Oh, wait, no, because it's a weak acid, because, okay, it'd be H2CO3 would be what it would when you add water to the CO3 for HCO3 is 1. So it'd be basic, so it'd be greater than 7.
Okay, now this one's tricky. This is an amphoteric one. Okay, so it could either react with water to make a base or an acid, and so you have to look it up and see which is more likely to happen. And it's more likely to do the top reaction, and so it's basic. So you'd have to look up the Kb and the Ka. Did anybody think of doing that? Yeah. Ooh, all right. You thought of it, but you didn't. But no, you did. Okay, you guys good? All right. Then we're going to take that quiz, and then when you're finished, there's a paper to pick up on hydrolysis. We actually just did this, okay? So that one's done. This is going to be done, and all you'll need to do is the worksheet that you pick up, the first 5, okay? I'm going to turn this off.